Hello everyone. In this video, we are going to discuss about canonical product of sum, that is called as POS, using truth table method. So previous videos we have seen how to derive canonical sum of products, okay, using truth table as well as algebraic method. Here you are going to see how to derive canonical product of sum, that is POS. When a Boolean expression is represented purely as product of max terms, it is said to be canonical product of sum form, right? Here you can see the previously for SOP we used min terms, and here you are going to use max terms. Okay, so we will be seeing what is max terms and how to convert this truth table into canonical product of sum form. Okay. Now, it is also called max term canonical form of Boolean expression. So, it is the canonical product of sum also can be called as max term canonical form of Boolean expression. So, it is another name which is used. Now, you are going to see using truth table method. Okay, you can see prepare a truth table, a table of input and outputs. Add one additional column of sum terms. For SOP we used product terms. You all already used that, you would have seen that in previous videos. We used product terms column and then we converted into min terms, right? And then you added all that, and then you got it as a sum of product. Here you are going to add another column called as sum terms. For each row of the table, a sum term is found by adding all the variables in complemented or uncomplemented form. Here you are not going to multiply, you are going to add up all the variables. That is a difference. It's like same like the previous SOP, but it is almost like inversing everything, right? It is just opposite to everything. So in SOP form we found the products, right? You multiplied all the variables. Here you are going to add up all the variables and then finally multiply all the terms. Now, for example, you can see x equal to 0, y equal to 1 and z equal to 1. Okay. So, here how to write the sum term? It will be like wherever you have 0, you have to write the normal variable as it is, and wherever you have 1, you have to write the complemented version of that variable. So, here it is just opposite to the SOP form, that is product term. Right, for some term you are going to write opposite, that is wherever you have 0 you are going to write the variable as it is, and wherever you have 1 you are going to write the complemented form. So, this is how you are going to get the sum term, or you can call it as max term. Now, the expressive product of sum form, the Boolean function f x y z, and the truth table for which it is given below. So, here a table will be given like this. You have to use the variables x, y, z as input and f as the output, and then finally derive the sum terms, and then finally get the derive the canonical product of sum. Right. Add a new column containing max terms. Now the table is as follows. You can see that, okay, 4 columns, 3 input and 1 output. F is the output, and you are going to add up another column called max terms, or you can write it as sum of sum terms. Right. Now, you are going to write complement and uncomplemented variables for each. Say here, for example, for the first row you can see 0 0 0 can be written as x plus y plus z. So, here it is uncomplemented version, okay, and you are going to add up all that. So, it is called as sum term, right? And for the second row it is 0 0 1. So, it can be written as x plus y plus z dash. So, if you got 1 here, you are going to write the complemented version of the variable, that is z dash. And then for the third row 0 1 0, you are going to write x plus y dash plus z, right? And for 0 1 1, you are going to write x plus y dash plus z dash, and for 1 0 0, you are going to write x dash plus y plus z. So, just opposite to the min terms where you will use, okay, for 0 you will use complemented version, and for 1 you will use uncomplemented variable. Here you are going to just write the opposite, okay. For 1 you are going to write complemented variable, and for 0 you are going to write uncomplemented variable. So, you are going to just do the opposite of the min terms. And next you got 1 0 1. So, it is x dash plus y plus z dash, and then 1 1 0 you got x dash plus y dash plus z, and finally 1 1 1 you are going to get x dash plus y dash plus z dash. So, it is just look like an reverse process, right? You read it from the bottom, you will get the minterms, right? Now, multiplying the max terms for the output of zeros, okay, we get the desired product of some expression. Okay, now you are going to see where the zeros are. Okay, in the previous slide you can see you got only 3 zeros in the result form, right? You can see 0 here, second row, and then the fourth row, and then the sixth row you got zeros. You are going to take only these max terms, right? You are going to take only these max terms, and then you are going to multiply these terms to make it as an canonical product of sum. That's it, right? Same like min terms, but there where you are taken, wherever you have 1 for product of sum, you are going to take only wherever you have zeros. Okay, whichever result column you have zeros, you are going to take only that max terms and write. So, that's how you got this x plus y plus z dash into x plus y dash plus z dash into x dash plus y plus z dash. So, this is how you got this canonical product of sum. Hope you understood this video. We will meet you in the next video. Till then, thank you.